Guys, really quickly, I just kind of want to walk through the steps we take in order to solve a trig equation. But with respect to trig equations, I suppose the idea is this. I just want to know what would this angle theta have to be in order to make this true. So it's this constant struggle of working backwards. I would tell you that when you're solving a trig equation, the first and foremost thing we're trying to do is to isolate the trig function. So if possible, I'll even write a note here, if possible. Let's see if it'll let me type. Isolate the trig function first. If not possible, then try setting the equation equal to 0 and then factoring. Then set the factors equal to 0 individually and isolate the trig functions. So the name of the game is this. I'm not sad if you're upset about this. What you have to do is get the trig function by itself. Okay, so number one, get the trig function by itself. If this is the case and we had a function like this, 2 cosine theta plus 1 equals 0, then I would say that it would be actually kind of easy to get the trig function by itself. We could just, I could just write, subtract our 1 and divide by 2. By doing so, we get that cosine theta equals -1/2. And so step number one is always going to be, let us get the trig function by itself. Now, in terms of what I would do next, we need to get to the angle, which means I have to undo cosine, and our effective method or means for doing so is to use an inverse trig function here. And so by using the inverse trig function, what we get is a statement then theta, or what I get when I take the cosine inverse of cosine of theta, is equal to the cosine inverse of the right side, or -1/2. And this is what typically we've been putting boxes around. Now, our job is to work backwards to kind of try to figure out what these angles could be. So in terms of the steps we're going to take to do this, once I have this part obtained, we're always going to start by sketching where our angle could lie. So looking at the fact that cosine came out to be negative here, what this tells me is I couldn't be in the first quadrant because cosine would be positive there. But I also couldn't be in the fourth quadrant because cosine would be positive there. It tells me that my angles must either terminate in the second quadrant or in the third quadrant. Now, I'm always going to recommend that we drop altitudes here to kind of give us this impression that these are a couple of triangles. But the first thing we do is ascertain in which quadrants does our function terminate. The next thing is going to be what is the reference angle that it makes with the x-axis. And so what this does is it comes down to your unit circle. And I see here that cosine is -1/2. Now, the fact that it's -1/2 doesn't bother me that much. I just want to know, looking at my unit circle here, at what angle, 30, 45, or 60, is cosine equal to 1/2? And knowing that cosine are x values here, I know it must form a 60-degree angle with the x-axis. And so what this means is I can go here, and I can go here, and at least put in that both of these are 60 degrees with the x-axis. So our last step is always going to constantly be, so what are our angles in standard position? And so that idea would be, if we were to leave the positive x-axis and go counterclockwise until we run into these, what would these two angles have to be? And so in this particular case, we would get, well, 180 minus 60, so that'd be 120. And we would also get 180 plus 60, which would be 240. So the idea is this: isolate that darn trig function, because once you do, we'll hit it with an inverse. Once you do that, then we're going to say, what quadrants can I be in? What reference angle must I have? And then therefore, what must my true angles be in standard position? Cheers.